Okay, we're having a current discussion about letting people come in and sit up front. So I hope we can do that. That's great. I'm really excited that so many people showed up, but I have kind of a cold shower announcement to make. I'm not giving anything away. So, although that's not entirely true, I'm giving away information and knowledge, but nothing that physically that you can take home and give to your kids if that's what they're expecting. So I'm going to talk about HTML5 from a performance perspective. But first, I'm going to start off and give a little background on my work in working on web performance and kind of the motivation. I think probably a lot of people, how many people here build websites? Yeah, okay, great. So I think there's something in the DNA of engineers in general, and especially programmers, to be efficient and optimize. I think as developers, we all like our code. We feel proud if we can say about our code that it's really fast and efficient. And so at the beginning, I'm going to talk about how we can try to work to instill that interest and buy-in for performance across other parts of the organization outside of engineering. So there'll be a little preamble on that, and then we'll dive into the HTML5 stuff. I just want to mention the slides are up on my website, stevesouders.com. If you go there, there's a link to it if you can't remember this long URL. And I encourage you to check that out. OK, so let's get started. So, the other thing I want to mention is really more than what I say and more than the words on the slides, I really want people to pay attention to the photos in the background of the slides. Come on, let's loosen up a little bit, let's go. I mean, like the story of my life, like I take slow things and make them fast. Like, is that very appropriate or what? I need more feedback. Yeah, okay, there we go. So, I worked at Yahoo for a long time, 8 years. I went there I was going to be there 1 year. I was there 8 years. And about 4.5 years ago, I joined Google, which was really my goal when I first started on web performance, because I knew the people at Google really cared about making things fast, and it's true. So I've been there 4.5 years. I do mostly open source stuff. So I created YSlow, Kazillion, SpriteMe, Hammerhead, Browser Scope. Lindsay Simon now runs that project, a very successful project. JDrop, which is a great concept, but not such a successful project, but you should check it out. HTTP Archive, another one I don't have time to talk about today, but just check it out, httparchive.org. I wrote high-performance websites, even faster websites. I taught at Stanford based on the books, and I run the Velocity Conference. Oh, I got to update. We just had it this week, in fact. I just finished that on Wednesday. So I've been doing this performance stuff for quite a long time now, 7 years, I think. But when I started back in 2004, I kind of felt like the lone voice in the woods. I'm sure there were people that were working on it back then, but when I searched for information about making websites faster, I really didn't find very much. There was a great blog post from David Hyatt that actually really opened my eyes to where I should look for making websites faster. I should mention that when I talk about performance, I mean that from the end user's perspective. My goal when I started this in 2004 was to make the user experience fast. Now, there's another aspect of performance which I think of more as efficiency or scalability on back-end servers. How can we handle 10x the current number of users with the same hardware? Those kinds of efficiency optimizations are also performance, but when I say performance, I really mean speed of the user experience. So when I first started working on this, there really wasn't that much information out there, and I would try to go, I started documenting things, writing books, blogging, trying to go to other teams and convince them to focus on performance. And it's kind of like QA or writing unit tests, like, try to sell unit tests, time to build unit tests to someone from marketing or sales. That's kind of hard to do, because it's hard to visually see the benefit of that. And so at the beginning, it was kind of the same thing with talking about make the website faster. Yeah, we need like a couple people to work for at least 6 months, and you won't see anything different on the site. It will just feel faster, and believe me, that's really critical. And they're like, no, really, we want you to add more Flash. And so fast forward to 2010, Future of Web Apps. We have Fred Wilson. How many people know Fred Wilson? Like one of the most prolific bloggers. He's the #1 VC out of New York City, out of Union Square. So he's a very techie guy, but really his business is investment, funding startup companies. And here he is speaking at a tech conference about his 10 golden principles of successful web apps. What's number 1? Speed. He says, first and foremost, we believe that speed is more than a feature. Speed is the most important feature. And he goes on to talk about how with their portfolio companies, they track all of the company's performance, speed, page load time for real users, and that in their experience, the data shows that when the speed drops off, the success of the business drops off. And that's why they do this for all the portfolio companies that they work with. And so, I think that's, to me, like, web performance has arrived. We have a VC talking at a tech conference about speed. Like, this was beautiful to me. I start almost every slide deck with this slide. And actually, a partner of Fred spoke at the Velocity conference this week. And in addition, if that's not enough to have the #1 VC out of New York City talking about performance, I'm going to run through a bunch of case studies here that correlate performance speed to the success of the business. So here's about 2 years ago, Bing and Google Search got up on stage at the same time and talked about experiments they had run. Bing introduced intentionally a delay in serving search results. They took it up to 2 seconds. At a 2-second delay, they saw all their goodness metrics drop off. Most significantly, revenue per user dropped off 4%. Google took it up to, and of course, these companies are doing this on a very small sample size. So Google took this up to 400 milliseconds at the max. Didn't see that much drop off in searches per user, although at Google scale, that's a fairly significant drop off. The thing that was really interesting about this study was after they removed the delay, they kept that user group segmented and tracked their usage. And it took, I think, 6 weeks for the usage, the searches per day, and other goodness metrics to resume where they were before the experiment started. So this, the user's awareness of what the experience is like is something that gets ingrained and lives with them, and it takes a long time to build that and also to recover from delays. So it's important to stay on top of keeping your website fast. And Yahoo ran a similar study, and for full page traffic, that means traffic where the onload event actually fires, a 400 millisecond delay saw a 5 to 9% drop off in traffic. Here, Mozilla, this is about a year old. Mozilla, when you want to upgrade to Firefox and you're in Internet Explorer, you get the IE landing page, and they made that IE Firefox landing page 2.2 seconds faster, and they saw a 15% lift in Firefox downloads. So for them, that's their business metric, being a nonprofit. And this was a seminal study from Velocity a few years ago. Shopzilla did a tremendous performance optimization effort, taking their site from 7 seconds to about 3 seconds, and they saw conversion rate go up 7 to 12%, depending on the country. This is very significant. They saw the unique users from search engine marketing more than double. And this was the first study that showed another benefit, in addition to the business metrics, is operating costs going down. So here we have the number of servers needed to run the website after this optimization dropped. And that kind of makes sense because like one of the optimizations is concatenate scripts together. So instead of making 7 requests to my server, I'm only making 1. Turn on gzip, so the amount of time it takes for the response to get off the server box is lowered, and so the server can handle a higher QPS. And then following that, a good friend of mine, Bill Scott, when he was at Netflix, they hadn't they didn't have gzip turned on for some reason I can go into after if people want to ask. And he turned it on one day, and the NOC paged him and said, the website's down, all we're serving is the error page. And he said, why do you think that? And they said, the traffic in our data centers dropped in half. He said, nope, we're serving everything. It's just that we turned on gzip. So this is probably 6 figures a month for traffic out of a data center that they saved. Pretty significant. Here's another example. Edmunds.com turned on, added an expires header so that their resources through their CDN could be cached, and they saw their CDN traffic drop by 1/3. So again, this is probably a 6-figure, maybe high 5-figure savings per month from CDN costs. And then, not that recently anymore, this was about 1.5 years ago, Google announced that speed or latency was going to be taken into consideration for PageRank. And that was caveated. It's one of 200 signals. It only affects about 1% of search results, but still it's a consideration, and PageRank is really important. So all of these things about 1 year, 1.5 years ago I saw coming together, and so I coined a new catchphrase for this emerging industry called WPO. It stands for Web Performance Optimization. And actually, as I mentioned, I keep mentioning, we just had Velocity this week. There were a number, Sequoia, Battery Ventures, Excel, Union Square were all there. This industry is really growing up. There's a number of startups in this web performance space now. And the elevator pitch is it drives traffic to your site. We see that with search engine marketing, with PageRank. It improves the user experience. You would think that making websites faster, the user would get in and out more quickly, and it's just the opposite. All of these studies showed that page views per session, session length, all increase because the users are having a better experience. It increases revenue. We saw stats on that with conversions, downloads, and it reduces operating costs. So this all sounds pretty good, right? So WebPO is really taking off. All right, that's the preamble. How many people here think fast websites are good? All right. So hopefully, if you're having trouble selling that, if this is stuff that you want to work on and you're having trouble selling that back home, you can take some of these case studies and show people back home that this is a good investment. You'll actually get a positive ROI. And maybe these will give a little guidance on what you can track on the business side to actually correlate performance improvements with the goals of the business. All right, so let's transition into the meat of the topic. I don't want to debate about what HTML5 is. There's the spec. I also mean CSS3. It's the new stuff. So I'm going to highlight a few things around HTML5 and CSS3 that I think are really important to pay attention to from a performance perspective. So the first is, if you want to optimize something, you need to be able to measure it. And right now, what we'd really like to measure is the user's perception of speed. And currently, there's no way to, there's no JavaScript handler for brain activity. So what we've been using as an industry as a proxy for that is the window onload event. Now, the problem with that is, for example, if I do a Google search and I click on a search result that takes me to Whole Foods, and I want to measure, from Whole Foods' perspective, they want to know how long it took for the user to click that link to when Whole Foods was ready. And the problem is tracking the start time. How do you track the time that the user started by clicking on that link? Because that's the user's perception time. And what you can do is, at the top of the Whole Foods page, you can put a script block that takes a time measurement, but that totally ignores the time it takes for the request to go up to the Whole Foods server, for it to stitch together all of the content and send that back down to the browser. And so about 2 years ago, Google and Microsoft formed this web performance working group as part of the W3C. And the first task was to create the web timing spec, which is actually 3 specs: navigation timing, user timing, resource timing. How many people here use navigation timing to measure websites? Good. It's not good that there were so few hands up. It's good because I'm going to talk about it a little bit. So those are three. I'm going to talk about each one in a little bit more detail. They're also working on a few other specs. Page visibility, I'll touch on quickly. Script-based animations, I'm not going to spend too much time on, but people are doing a lot of animation with JavaScript, and they're working on making that better. And efficient script yielding, since the browsers are single-threaded, if you have long-running JavaScript, it can really degrade the user experience. So what can scripts do to mitigate that? But let me talk about the timing specs. So navigation timing actually is out. The spec is done, and it's available today. If you look at window.performance, there's this timing object, and you can do things like from the timing object, you can get the navigation start and the load event end, take the difference. And the nice thing is that the web timing spec gives us two main things. This is the first one. This is the time at which the epic time at which the user clicked on that link on Google, right? And so now the user can get the website owner can get the full time from when the click happened to when the onload event or whatever event you wanted to. And in fact, if you put a little timestamp at the top of the page, you can break that into what I call the back-end time, the time from the click to when the first byte arrived, and the time from the first byte to when the full page loaded. And there's a bunch of other timings in there. You can get DNS time and connection time. So there's a bunch of time values that you can get in there. And so this has been out. The spec was finished probably about 6 months ago, maybe a little longer. And I think IE9 was, no, I think Chrome was the first to implement it. But it's in IE9 and up, Firefox 7 and up. They had some bugs in the Firefox 7 in the early days, but those are all fixed now. It's on Android, and I heard a month ago it's on BlackBerry, but I haven't tested that. And here's a good URL from Tony Gentlecore that kind of explains how you could use it and some examples of getting different time values. So one thing that's really cool is Google is taking, for PageRank, is taking time into consideration. But when they announced that, I'm really proud of the work from the Make the Web Faster team at Google, where it wasn't like, okay, we're going to hold you responsible for it, good luck. We also rolled out several tools. In Webmaster Tools, you can go in there and you can see how your site compares, its speed compares to the rest of the industry. And really, the folks who are going to get penalized from a PageRank perspective are going to be in the lower 10%, maybe even lower than that. So, you know, if you're in the, maybe you're not awesome, but if you're in the top 50%, you probably don't have too much to worry about there. So that's a little help. But the other thing that's really nice to get a little more granularity is if you use Google Analytics, we added this time measurement capability into Google Analytics. Under Google Analytics, I think we call it site speed. Yeah, site speed. Yeah, this screen dump is a little old. I think the UI is a little different now. But the nice thing is when we first launched it, you had to add a little bit more to your Google Analytics snippet. And then about 3 or 4 months ago, we turned it on for everyone. So even if you had no awareness of this site speed time measurement capability, you've been gathering data for about 5 months now, 4 or 5 months. And so you could go to Google Analytics and go and find this site speed tab, and you can actually get charts. And it's the usual Google Analytics slice and dice capabilities by browser, by geographic region, by page. And you can see what your performance is. This is my website, so I don't know what was going on there. But that was a while ago. See, now it's fast. Well, in November it was fast. Thank you for that. I appreciate it. I think I probably, yeah, so now it's on by default. Oh, it's only in browsers that support nav timing. So we really need mobile browsers to start supporting this more. It's sampled. So by default, it's a 1% sampling rate. If you have a huge website, like 1% is probably fine. And the guys have done a really smart thing. Like they don't start it at midnight. And if you're a huge website, you've used your 1% by 12:15. They like dole it out throughout the day. But you can, if you're a smaller website, you can change it with some Google Analytics commands to cover 100% of your website, but it's limited, I think, to 10,000 measurements a day, But again, those will be sampled throughout the day, so you won't get biases based on peak time and stuff like that. And then I'm just going to talk really quick about the other two parts of the timing spec. There's resource timing, and this is, there's drafts of this available, but this hasn't been nailed down. I don't think there's any browser that supports it yet because the draft is, the spec is still being defined. But this, if you think about it, navigation timing is basically this same information, but it's at the page level. It's really high. And what we're doing with resource timing is we're bringing that down to every HTTP request in the page. So for every HTTP request in the page, you can get DNS lookup time, connection time, total time for that to come back. This is going to be a great mechanism for if you're using a CDN to track how your CDN, or maybe you're testing out multiple CDNs to see how their performance is going. It does have to worry about security safeguards. So you could have some kind of hack where you know, on my website, I have the logo from some nefarious website. And when you land on my website, I can actually see what the DNS time is. And if the DNS time is 0, I know that you've been to this other website. And so there are some security safeguards with HTTP headers. Websites can allow or not allow cross-domain tracking of resource timing. And then there's also user timing, which is really important for people building Web 2.0 apps, AJAX-y stuff. Something like Gmail that is open for several hours, there's no concept of like a page load time. There's only one of those when you start it up. So this is, if you're doing AJAX-y stuff like compose, this will give you commands that you can use to say, the user's about to do a compose operation. Let me mark a start time, and then when the compose is all done, you can mark an end time, you can give it a label, and so it lets you define and track any timing episodes that you care about in the web apps that you're building. So it basically is like nav timing, but it's much more flexible and lets you to define the start and stop times wherever you want in your code. The other one I mentioned that they're working on is page visibility, and this one is important from a performance perspective, mostly from a altruistic perspective, but it could also affect the, you know, what you're doing on your website. And so basically what the spec lets you do is detect when your page is visible. So like one thing I do in the morning when I come in, since I can't stand to wait for websites to load, is I have this script and I boot up my machine and I load this script and it loads my 30 websites that I read every morning. And then I go get breakfast, and when I come back, all the pages are loaded and I can just go through all the tabs. But only the top tab is visible. And inevitably, when I come back, if I left my sound on, my office mates are giving me a dirty look because there's some hidden tab that's playing video and the sound, or maybe multiple tabs that are playing video, and the sound is just annoying. And it's like, really? Like you started the video even though like the tab's not even visible? Like why did you do that? And the page visibility API introduces a way to detect whether or not the tab, the window is visible. And so this is also really important, like if you're tracking metrics like page impressions, if the user opened the tab but they're never going to go to it, but you counted it as an impression, that's a miscount. Same thing with ads. Again, the example of video, you might be doing something like showing them stock updates or the latest messages from friends, or you might be rotating through a carousel of photos and they're not looking at it. So not only are you kind of, like you might rotate through a carousel of photos that started with their favorite photo, but by the time they actually open the tab, you're down to their 57th favorite photo, and you kind of ruined the user experience for yourself. So you could use it there. The other thing you can do is this API can be used for prefetching resources. And so the website owner can decide, the website owner can decide if they want to prefetch resources maybe for the next page, and also if the page should be pre-rendered. This is something that Chrome does. So Chrome can actually pre-render a page in the background. But one of the problems with doing that is, again, if there are ad impression counts or page impression counts that are firing, and the page is being rendered in the background, and the user actually never sees it, that's a miscount. And so the page visibility API gives people controlling those metrics the ability to only fire the metrics when it makes sense. And I think this is only in Chrome right now, but what it looks like is you can say WebKit hidden is the property you can look at to see whether or not the tab is hidden. And this is a event handler you can attach to detect when the page does become visible. So we had script defer and IE for years, but now with HTML5, the async and defer attributes are officially supported across almost every browser out there. I'm not going to go into it here, but in fact, I've talked for years and written extensively about the impact that scripts have on the user experience. So I mentioned earlier how the UI thread, the UI is single-threaded, the browser is single-threaded. So if you have JavaScript, for example, that takes 3 seconds to execute, the user is clicking in the browser and they're trying to scroll the window and nothing is happening because the JavaScript is blocking any of that interaction. And so that also happens when the script is being downloaded. So if you have a 500K JavaScript payload and the user has a slow connection, again, it can take seconds for that to download. And while that's downloading, the UI could be blocked unless you can do your script loading asynchronously. So if you just do script source equals main.js, it's going to stop the HTML parser from parsing past that script tag. And it's also going to block rendering. No browser in the world will render anything below a script tag until that script is downloaded and parsed and executed. But you can use the async attribute, which tells the browser to start the download, but go ahead and continue parsing the HTML and rendering the DOM elements in the page. So it gives the user feedback. It's a better user experience. The user can see the page rendering, especially because a lot of times we put scripts in the head of our pages, which means the entire body is blocked from rendering until all those scripts are downloaded, parsed, and executed. And so this tells the browser, download it in the background, continue parsing, and as soon as the script arrives, parse and execute it. So two tricky things about this is you can't have any document.write in this JavaScript code because the parser has already passed that point, and you're going to get very bad and varied results across browsers if you do document write in an async script. The other challenge with async is, suppose I have 3 scripts, A, B, and C. C depends on B, B depends on A, but A is probably like jQuery, so it might be my biggest script. C might be really tiny. So if I load all of these async, which is the one that's going to come back first? C. And if I load it async, it's going to be parsed and executed as soon as it comes back, and it's going to get undefined symbol errors because B might not be back and A might not be back. So you can't just willy-nilly add an async attribute to all your script tags. But what you can do is you can use defer. If it's JavaScript that isn't critical for rendering content in the page and doesn't have document.write, you can add the defer attribute, and it's pretty similar. It says download it in the background, let the parser continue parsing and rendering DOM elements. After the entire page is done, parse and execute these deferred scripts and do it in the order that they were listed in the page. And so if you have those interdependencies across scripts, defer is a good fallback. But this still doesn't give all the control that I think is really needed to build a good user experience for web apps, especially on mobile. For example, one thing I would like to do is I would like to download maybe a big script, 100K, 300K, 500K, but not parse and execute it. It might be a script for something like popping up a div to compose a message or address book stuff that is only needed if the user starts typing an email message. But if I download that, as soon as it hits the browser, the parse and execute is going to happen and it's going to lock up the UI. So I really want to get this JavaScript down to the device, get it in cache, but parse and execute it depending on what the user does. The other thing I'd like to have is control over when the download happens. Right now, the spec doesn't say when browsers should download the script, but if I've said defer, if I've said async, certainly if I've said defer, I would like you to do this download after everything more important is already done, because there's a limited number of TCP connections that the browser will make. And if you download scripts or multiple scripts, then things like the background image of the page, the logo at the top of the page, might actually be pushed out because you're already using the 6 TCP connections that most browsers allocate to a domain. So we don't have control over those in markup, but there are techniques you can use to get that behavior. So this is one that Gmail wrote about quite a while ago, Gmail mobile team. And it's a hack. I think it's a beautiful hack. So what they did was, in the page, they have maybe 300K of JavaScript. I'm just making these numbers up. I don't know how much JavaScript Gmail has. It's probably more than that. But they have a lot of JavaScript in here, and they just wrap it in comment delimiters. And so what happens is, this will get downloaded to the browser. It'll be cached. It's already resident, but it's not parsed and executed. So let's say this is compose a new message JavaScript. It pops up a div. It formats everything. It does error detection and things like that. So we don't really need this JavaScript to block the UI thread for parse and execution until the user actually clicks on the compose button, which they may never do during this session. So what we do is we download the code because we want it on the device. When they click compose, especially on a phone, we don't want to wait to download 300K of JavaScript. We don't want to make the user wait. So what we do is we download it. You can even download it in the background because it's not going to block the UI thread when it arrives. And now the user clicks compose. You have all the JavaScript on the client. And now you just find the DOM element for the script tag, remove the comment delimiters, and eval the code. A lot of people say eval is evil. Doug Crockford's here today. I saw him downstairs. He'll tell you that. Certainly eval is evil from a security perspective. If you're evaling code that you didn't generate, that can produce really bad things. Like, you wouldn't want to do this with third-party widgets, ads, et cetera. But this is code that you control, that you generated. So from a security perspective, it's okay. And the actual performance of eval is less than 10% worse than just a script block. So from a performance perspective, it's actually down like around 1 or 2%. So from a performance perspective, it's fine. So you control the code. Performance-wise, it's good. So this is a really nice hack. And it's perfect for prefetching JavaScript that you might need, but you're not sure. It's possible that you'll never need it. So don't block the UI thread, especially for large amounts of JavaScript. This might require a fair amount of rewriting on your website. So I wrote something called Control.js. It's open source. You can get it off my website. Several big companies, I was just at this conference, and I found, including Walmart, I found several big companies that were using this that I was really surprised at because I don't do a lot of testing. I trust that they've done that. And actually, who else is using it? Washington Post is using it. And I asked them to contribute back the robustness changes they had to add. And so the thing I like about this technique is it's all done in markup. So we can just change, instead of script source, having type text script, we'd say text CJS. And instead of a source, we have a data Control.js source. And so this means that the browser will basically just ignore this. And you can also do it with inline scripts just by changing the type. And then you load Control.js. And what it does is it crawls the DOM, and it finds these script nodes, and it does the right thing. It downloads it asynchronously. It does it in the background. Again, you would only do this with scripts that aren't critical for generating the initial user experience and scripts that do not have any document.write. But I think it's a little easier to get on top of. And you can even add this execute false, which says download it, but don't parse and execute it. And then later, when the user, for example, clicks on the compose button, you can say Control.js execute script. So that's kind of a nice alternative. The other thing I like about it, how many people here have played with JavaScript loaders, script loaders, lab.js or YUI loader? Some people. The thing I find ironic about all the other alternatives out there is Their goal is to help you load JavaScript asynchronously, and they do that with a helper script, but you have to load their helper script synchronously. Anyone else think that's weird? Like, you know, synchronous loaded scripts are bad, so you load our script synchronously and we'll help you avoid that problem. So from the beginning, one of the requirements of Control.js was that you can load it asynchronously. So you can use the Google Analytics async loading pattern and load the script anywhere you want in the page, and everything will still work. So JavaScript is a really, really big problem. Make sure that you look at how it's impacting your website, and if possible, adopt some of these asynchronous loading techniques. Okay, shifting gears, I wanted to talk about app cache, which is good for offline apps and also for longer caching. So again, the importance of the background photo. You're in the desert. You typically don't have a good connection. So having offline apps is really important. There we go, the groan. So building offline apps is really cool. I think Google Docs just announced that this week or last week. It really helps with the user experience. When you're, have a bad connection, you're flying or whatever. But also people are using it from a performance perspective for better caching. So this is a study I did 5 or 6 years ago with Tenny Toyer when we were at Yahoo. And it's been a long time, but I've talked to people at other big web companies who have run the same experiment, and they basically get the same results. So I encourage you to run it on your website. Basically, we put a hidden pixel in every page, and we tracked how often people made a request with or without a if modified since header. If they send a if modified since request, it means they have it in the cache. If they don't, it means they don't have it in the cache. So we can track how many people coming in and how many page views are done with a full cache, a prime cache. Our resources are in their cache, or with an empty cache. Our resources are not in their cache. And so like I talk about in my best practices, setting a far future expires header, but it turns out even if you do that, browsers aren't going to keep things around for that long. Or for whatever reason, users are going to come in and they're not going to have everything in cache that you might expect. So what we see here is that for page views, if we look at it from the page views perspective, about 20% of page views on any given day are done with a empty cache, right? My resources are not in the cache. You can see on the first day, when we put this pixel in the page, 100% of the pages had an empty cache because this image had never been loaded before. And after about 2 weeks, we hit a steady state. And we can see it's about 20%. We ran this on various properties at Yahoo that had different user metrics. And this was always about the same. This number fluctuated a little bit more, but it was always between 40 and 60%. About half of your users come in at least once a day with an empty cache. So why are these numbers different? Typically, users are doing multiple page views in a session. So even if they have an empty cache, they'll come in and they'll have an empty cache page view, which will show up here and show up here. But then they might do 3 or 4 more page views, which are going to be a primed cache, because when they did their empty cache page load, stuff got put into the cache. So that's why these numbers are different, but it still means people anchor on negative experience. And so if half of your users are coming in every day with an empty cache, and you're not taking that into consideration, you're like, well, yeah, it's a 300K image or a script, but it'll be in the cache. For about half your users, it's not going to be in the cache. So you can run this experiment yourself, and I guarantee you, you're basically going to get the same results. So the cache, even if you are doing far future expires, the cache might not be doing what you think. And here's a great study from Guy Poe over at Blaze, now Akamai, where he shows that mobile caches are very small. This is another reason why things you think should be in the cache won't be. And this was a study I did where I found that I like building web apps and putting them on the home screen. And it turned out in iOS, if you do that, the cache isn't used optimally. So you can use app cache for caching. The way that you use app cache, you add this manifest attribute. You give it a file name, which is your app cache. Manifest is a good name. I think we all kind of intuitively recognize what we're going to see here. Here's your manifest file. It has to start with this cache manifest header. We'll talk about the revision number in a second, but you'll want to add that. And it's got these various sections. A cache section says, these are the things I want you to put into app cache. The network section says, these are the things you should never put into app cache. And the fallback section says, if the user's online, then use this URL, but if they're offline, read this one from app cache. So the browser, when the user's online, will download this one, but will also download this one and save it into app cache. And at least right now, you have to make sure to give this a very specific content type, text/cache-manifest. So it looks pretty good. It turns out that actually it's really, really hard and complicated to work with. So here are some of the gotchas that you'll probably run into. I know I did. I didn't realize, like I never listed my HTML document itself, .php or .html, in the manifest file. So I just assumed it wouldn't be put into app cache. But if your HTML document uses the manifest attribute, then it's going to be saved into app cache. This was really confusing for me because I had a login box on the front page. And if the user came in and their app cache was empty and they weren't logged in, the logged out version of the page would be saved every time they came back. That's what they would see even after logging in. So that's a little confusing. If anything in the manifest list, 404s, nothing is saved. You get about 5 meg, which is pretty good. Yeah, so this is interesting. Suppose you change one of the resources listed in the manifest file, like an image. You would think that the next time the user opens the app, they would see that new image. They don't. You actually have to change something in the manifest file to make it different. And that's why the revision number was in there on the previous slide. That's what I do, is I have that automatically updated whenever I update through source code, through my source code control system. It will automatically update that revision number. So the manifest is always touched whenever I update a resource. And this was really confusing to me. Even if you do rev the manifest file, the user still won't see the change until the second time they open the app. So I think this is really interesting, and it's a real gotcha, so I wanted to walk through it in more detail. So let's suppose you go home today and you build a mobile web app that uses app cache, or a desktop app that uses app cache. And it's got this awesome green logo that the designer gave you. And so you list that in your app cache manifest file. So you push that tonight. Tomorrow, the first user ever downloads your app, and the app cache is obviously empty. They've never seen this before. And so the browser fetches the manifest file, and in there the logo is listed, so the browser downloads that, puts it into app cache, and renders the app to the user so the user sees the awesome green logo. So now suppose tomorrow night you go, I really think an orange logo would be better. So you push to your server this new orange logo, and you remember to change the version number in the manifest file. So the logo is new, the manifest file is new. Hey, Doug. And on today's Friday, so you do that Saturday night. So on Sunday, the same user loads the app again, and the browser says, okay, well, this app has a manifest file associated with it. Do I have any of those resources in my app cache? Oh, I do. I need logo.gif. Well, I have logo.gif in my app cache. It's this pretty green logo. Even though I've already pushed an orange logo to my server, the browser's ignoring that. That's why it can work offline. It can say, I have this stuff in app cache. Let me load as much as I can without using the network. And so it displays that app cache logo to the user. But now what it does is once it's rendered the app with the old out-of-date logo, it fetches the manifest file, it detects that it's changed, and so then it checks all the resources in the manifest file, and it gets the new version of the logo, which is orange. It saves that to app cache, and so if the user reloads the app a second time, the browser will look in app cache, and now it has the orange logo. So it renders the orange logo to the user. It fetches the manifest file, which hasn't changed, and so it's done. So it's really taken these 2 loads. After I update a resource, it takes 2 loads for the user to see the changes. Now there is a workaround to this. It's not that hard, but not that easy. There's this update ready part. The implementation is pretty easy. I can track this, but it's what do I want to do with the user experience. So in the background, the browser detected that there was a new logo, and it fires this update ready. But are you going to tell the user to like reload the app to see the changes? I don't know. You have to decide for yourself. Maybe if it's just images, it's not that important. If it's like an important JavaScript security privacy fix, then yeah, maybe you want to tell them to reload it, or you want to reload it without even telling them. Just reload the app. Another way to do improve caching, because we know the browser cache doesn't work super awesome, is local storage. Really simple API. Local storage is persistent across sessions. If you only care about session, you can use session storage. It's about 5 meg. One warning, browser developers really are worried about this getting too much use because it does a synchronous read. Some browsers will actually read everything out of local storage the first time you go to that page during a session. And if you have a lot of stuff in local storage, again, it's single-threaded, so that could slow down the user experience. So I built this bookmarklet that lets you look into what's stored in local storage. And I discovered a couple of interesting things that Bing and Google Search were doing, which I hadn't thought of. And it's very cool to help with caching. So I think this is the Google mobile search implementation. The first time you do a search, the HTML document will return all of these inline script and style blocks, a lot of JavaScript and CSS. And when it's done, it iterates over those script tags and style tags that have IDs, and it takes the content of the block and writes it into local storage based on the ID of that element. So now, after I've done this first search ever on my phone, I have blocks of JavaScript and CSS in my local storage. So now let's say I do another, and the other thing it does is it sets a cookie that says which blocks of JavaScript and CSS have been written into this user's local storage. So now if I do another search, this cookie goes up to the server, and the server says, oh, well, you're doing a search. I have to give you this block and this JavaScript and this CSS. Let me see what you already have in local storage. It looks at the cookie, and it says, oh, you already have this block. I don't have to send you that. I don't have to send you this CSS. And in the case of mobile search, it drops the download size from about 110K to just 10K, because all of that stuff is now in local storage. And then when the lightweight page arrives, there's some JavaScript that will pull all of these things out of local storage and write them into the page. So this is a really cool way to get more persistent cache. Local storage is unaffected by other websites, whereas the shared browser cache, if the user visits a bunch of other websites that have large resources, your content might get pushed out. So I did a quick survey using, this is what this, I'm a good JavaScript hacker, I'm not a good UI designer. So this is my awesome storage or bookmarklet, and you can see it just lets you look at what's in the local storage and session storage, tells you how big it is, how many items it is. So let's just do a quick run through the Alexa top 10 and see how local storage is being used. So here we have Google Search is using it on both mobile and desktop, so that's one. Bing is using it on mobile. Facebook is using it on mobile. Yahoo is maybe using it a little bit, but not really. We're not going to count that. YouTube, yeah, we'll count that. That's quite a bit of content on mobile. Amazon, no. Twitter, yeah, okay, we'll count that. 5. LinkedIn, no, I would say. eBay, no. MSN, no. So about 5 or 6 of the Alexa top 10 are using local storage. So that's an indicator that it's worth investigating. Why is it maybe used more prevalently on mobile? The experience of not having something in the cache in mobile is worse because the network connection speed is so slow. Also, the cache is smaller on mobile. So caching isn't awesome on desktop, but it's much better on mobile. So I think that's why these top properties started using local storage on mobile, but I would expect to see this proliferate on desktop apps as well. So I wanted to talk about font face. Again, pay attention to the photos, not to what I say. Fonts, using custom fonts can create a more compelling, beautiful experience, but people haven't really paid attention to what it does, similar to how scripts and style sheets can block a page, what custom font files do. And so I created this table that, here's the blog post, that shows how scripts and style sheets and fonts can affect. And blank below in red means that everything using this font or below it are going to be affected. Delayed means blank is really bad. It means like everything in the page is blank. Delayed means just the element that's using the font file is affected. Flash means once the things will render, but once the resource arrives, it has to be redrawn, and so it's kind of a jerky user experience. Things have to be re-rendered and repainted. So you can see the impact. Even the green good is not really a good experience. And so you want to use fonts kind of carefully. And it's kind of ironic. It's kind of like how these async script loader libraries make you load their scripts synchronously. When I talk to designers about why they're using custom fonts, even though we know it has this impact on the user experience, they say, well, these are the most important design elements in the page. I'm like, so you want the most important parts of the page to take the longest to render? Like, that doesn't make sense to me. So despite my warnings, custom fonts have taken off. Like, they've more than doubled in the last year. This is a chart from the HTTP archive. So they're taking off. The good thing is the folks at Typekit and the Google Fonts library have done a lot of good work to mitigate the impact that custom fonts files have. But we can still go farther. In fact, I think Google Fonts library just announced custom fonts a few months ago. You can, if you don't need, like if you're only using digits or other certain characters, like it's just a word that you want to render in that font, you can actually create a smaller font. The font files are typically like over 100K. So you can create one that's just the characters that you need. The flash of unstyled text means you draw text and then you have to redraw it. And so what I would propose is that browsers have like an impatient fallback. Like if I don't want to have this flash of my text, so I'm going to wait 250 milliseconds for the font file. If it hasn't come back, I'm going to draw it in a default font. And even if the font file comes back later, I'm not going to redraw it. I'll cache that font for the next time the user goes to the page, but I'm not going to do that. And again, I think this is a behavior that the Google Font Library and Typekit loaders do automatically for you. And also, okay, I'm running short on time, so I'm going to go a little faster. Fonts should be given a higher priority in caching. Browsers are still just starting to pay attention to that. And even if a font is expired, I might want to render with it and do a if modified since request. And then if I get back, oh, not modified, it's OK. I've already rendered with a font. All I had to do was validate it. Oh, good. I'm getting close to the end. So there's a lot more stuff I didn't talk about. All of us spent a lot of time building rounded corners that downloaded a bunch of images. So now you can do a lot of things that used to require HTTP traffic. You can do with CSS3. So that's cool. You have to be a little careful. These might incur a lot of CPU overhead or repaints. You can use SVG and Canvas instead of downloading images. Video tag could make starting up videos faster. WebSockets, if you have a very chatty sort of app, can be used. Web workers, if you have like a lot of computation that you want to get out of the UI thread, you can use web workers. For some things that we used to have to write a lot of JavaScript or HTML for, you can do with these new built-in controls. Again, the photo, more, an infinite number of digits. History API, we used to have to implement this in JavaScript. Now we don't have to download all that JavaScript. Ping is a way to avoid a redirect if you want to track something. Don't use set timeout for animation. Use request animation frame. It'll be faster. You can use the native JSON parser. And here's some good resources to get more information about this other HTML5 stuff. So what are the takeaways? Speed matters. Hopefully we all agree about that. I saw you raise your hand before, so I'm going to hold you to that. Pay attention to what's coming out of the Web Performance Working Group, out of the W3C. You can use window.performance to track the timing on your pages. And even if you haven't done that yet, if you're using Google Analytics, you can go and see the data there. It's already been gathered for the last few months. JavaScript blocking the UI thread is really critical. Try to get a lot of that stuff deferred or async. And caching is really important. I think it's one of the most important things for a fast user experience. Browsers are improving their cache. Mobile browsers have a lot of room to catch up on, so you can try some of these other techniques. And be careful about using font face. So before I close out, I just want to mention, if you like this kind of performance stuff, I'm sorry, but you should have been at Velocity this week. We just finished that Wednesday. But if you missed that, you could go to WebPerf Days, the first ever, but, oh, actually, that was yesterday. OK, so you missed that one. Oh, OK, we've got Velocity Europe coming up in October. So you might have to go a little farther, and we'll be back next year in June for Velocity. And I also wanted to just mention this. I added this like 5 minutes before I came on stage. How can I do this? Like, if I go like, oh no, I have to go through them all. So Stoyan Stefanov runs this performance calendar every year, and O'Reilly took the most recent performance calendar and put it into a book. So this just came out this week. And you can get most of this content on the blog for the performance calendar, but they were updated, and if you like books, you can get it in book form here. So that's it. Thank you very much. So I've got about 4 minutes. I'd be happy to answer any questions, and I think they want you to use the mic. Everyone's heading out.
Would you care to expound upon Font Awesome, and also to resolve some of the issues of the pop-in? I found setting a fixed height for whatever the text is inside is very nice.
What's the first one? Expound on?
Font Awesome, using fonts instead of sprites.
Oh. Yeah, so you can create a custom font, file that has little pictures instead, kind of like Wings. What is it on Windows? The Wings font, Wingdings, yeah. So you can do that with a font. So if you have like really small images that you're using now and you're downloading them as HTTP requests as images, instead you could download a font file. It doesn't have to be huge. Maybe you have 10 of those or 20 of those. And you can download those and use those to draw those little images, those little sprites in the page for like maybe little buttons or things like that. And so, I think that's a great idea. You could also use sprites. Sprites are maybe a little harder to do. You have to create the image and know all the CSS. But the one thing I would say, if you're using any kind of font file, is try to figure out a way to do it that doesn't block the page. Like especially in IE, custom font files block rendering of everything in the page. So if you could do that lazily or something like that, that would be good. And then the second one was?
Oh, it was just a tip to deal with fonts snapping in after they loaded. Is the ugly hack of just setting a fixed height for everything.
Oh, yeah.
So at least it doesn't like reflow.
Yeah, you could do that. Yes, another question.
You said mobile browsers don't support most of those features yet on custom, desktop browsers either. So how would we test them?
I guess I wasn't clear. Everything I talked about is supported in mobile browsers, pretty much. And in fact, you're going to get, I think that's another reason why we're seeing more HTML5 stuff on mobile than desktop. Because on desktop, there's still a lot more lingering IE6, IE7 legacy browsers out there. So you're almost a little safer using the cutting edge stuff on mobile than you are on desktop. The only thing I can think about is, I thought there was something, well, the page visibility API is only in Chrome. but all the timing stuff, local storage, fonts, app cache, async and defer attributes, all of that is supported on mobile too. Yeah.
Thank you.
Yeah. Okay, let's go here.
Let's see here. You're talking about visibility and document.webkit hidden and how that relates with click tracking and stuff like that. One-click unsubscribes in emails and things like that. Is that another way that we can avoid being automatically unsubscribed?
Well, but how would you, what's a scenario where you would render unsubscribe page without the user seeing it?
Well, if they're following links and preloading in the background, you might follow an unsubscribe link.
Oh, yeah. The pre-rendering I was talking about is the developer or user has explicitly asked to open a page, but we can just know we can do it in the background. But so, yeah, if you're crawling a page, that could be something that you could do is to make sure not to, you could instrument an unsubscribe link so that it only worked if the page was visible. Yeah.
Thank you.
Yeah.
What's your recommendation in terms of moving the script tags physically to the bottom of the body tag or versus using the defer script tag that you described?
Yeah, I think both of those work. One thing that I only have a few seconds, so one thing we don't have time to talk about is the importance of the onload event firing as quickly as possible. So in both cases with defer and async and putting scripts at the bottom, you're going to block the onload link, the onload event from firing. So really putting scripts at the bottom is almost the same as doing defer. It really has more to do with kind of the size of your team. A lot of times there's 20 or 200 people working on a property, and so it's hard to get the message out to put scripts at the bottom, or like someone's code is only going to be executed at the top, and it'd be really hard to give them a foothold in the top and give them also a foothold in the bottom and make sure that both of those are done in sync. So if the only place like the logging or metrics team has a foothold in the page is at the top, they can get the same behavior using the defer attribute as just putting the script tag at the bottom. But putting the script tag at the bottom is another lightweight way to avoid that blocking of the UI thread. Okay, so I should wrap up. Thank you very much.